check it. Yes. Yes, starts. Hello students, welcome to the IMS Gate Academy. Let's start the foundation course on operating systems. This is part of it, like no. Now we will continue the process concepts part 2. In the last session we have started the process concepts. So I have discussed like no, what is the difference between the program and process, the various definitions of process we have observed. Now let us continue the second part of the process concepts. Let us understand the various states of a process. Very good evening, Saurabh. Very good evening. So now we will see in this session the various process states and also process state transition diagram, the various possible transition between the process. That means simply the process activity we can observe right now. So let us start the session. So just let me recall the things which we discussed in the last class. So we have understand clearly what is a process. Yes. Can you recall what is a process? Process, right. And the process, like no, it's a definition we observed clearly. Definition, the various definitions I given. The followed by the structure of the process also we have seen. The structure or image or implementation or representation of the process we observed. Followed by various operations. Followed by various operations on process we observed. So then we will observe now attributes. The various process attributes we will observe right now. We will observe this one. So in this session we will observe the various attributes of a process. Yeah. Very good evening. So what I am trying to say, so just can you recall what is the process, what I discussed in the last class. The process is nothing but the notion of the process nothing but is a program but under execution. The moment process, the program image you bring into main memory for execution, the various resource we allocate for a program, so that become a process. Process is active entity, the various other properties also we observe. Very good, very good. The definition is absolutely fine. So that the meaning of that line you try to understand. The image is there, program image is there. The program image when you load into main memory, so when you make it active means what? When you load into main memory, that becomes active. Active thing is associated with the various resources like memory, files, CPU registers, CPU clocks. So many things it will start using. So that moment that we call as a process, correct. So now the process structure which I discussed also like kindly refer, like no, just I don't want to go depth of it, but the glance of the last class I am telling you, try to go and watch the previous session too. So you will get benefited. The various operations of process we have seen, like the operations are, so we need to create a process. So create a process, schedule it, schedule the process, schedule, and run the process, run, that means execution. So you can temporarily block the process whenever required IO activity. Then we can suspend temporarily, suspend the process, and finally we can terminate the process, right. The time of process creation, all resource allocation takes place, all resources, so all resources allocation takes place, time of process creation. At the time of process termination means end of execution, process completed its execution, so that it should release all the resources so far what it has acquired. The resource termination, the releasing happened the time of termination, resource allocation takes place time of process creation. This was a discussion happened in the last class. Now let us understand the attributes. What this attributes is talking about, okay, attributes. So process attributes. So process attributes. Put the subheading process attributes. Put the subheading process attributes. Yes. Are you able to understand? Yeah. So process attributes, like just I will put another way, the question I will put another way. Suppose if I take a student as an entity, what are the attributes associated with a student? Can you tell me what are the attributes of a student? Yeah, just I am expecting answer from you, Saurabh. A student, like no, the moment when we say the person as a student, the person as a student means when you register, when the person is registered in a particular course. Let's take when you register the BTech, the 4 years degree, so you become a student. The student necessary attributes, if we see, yes, identification, ID will be there. The student ID will be, student name will be there, student course duration, is address, age. So all things, all the given the required things for a student is or we can say student attributes. Similarly, in the operating system, please understand, the moment process get created, please understand, the various attributes also we keep, so that further decision we can take on a process. Exactly. Similarly, here also I will be classifying these attributes into like the different types here. First of all, identification related attributes. Identification related attributes. Identification means process need to be identified. Please understand, whenever a process get created, who is creating process? Operating system. Now operating system is going to assign a unique integer number to each process the time of creation. That indicates identification number. So through this ID only, operating system gonna identify a process. Please understand. So we call process ID. Is an integer number. Process ID is integer number. For classification, what you can do in Windows operating system, if you just open the task manager, you go and open the task manager. There you see list of process. The CPU utilization, memory utilization, IO utilization, it will show in terms of graphs also. You might have observed, otherwise you can go and see. In such list of process, there right side you see the process ID. ID will be based on the number of process, is integer number is assigned. So process ID. If the process is child is parent ID, process parent ID. What type of this group, the process belongs to which group? The like, category of a process, if you see, like user interactive process, background process, OS process, like this, what group the process belongs to. So these are related to a identification of a process. The second classification, just I made it CPU related attributes. CPU related attributes, please understand, what is the current value of the program counter? What is the purpose of program counter? It has some address of the memory location where program has been loaded. So that address will be there, it will point to that address, so that we can fetch instruction and we can start execution. And during execution of a process, the various general purpose registers it uses. So number of general purpose registers used by a process is varies from process to process, it will vary. So 2 register, 3 register, 5, 10, like that, depends on the architecture, depends on the process also. So general purpose register. Sometimes we will use special purpose registers also. Sometimes use special purpose registers. Getting my point? Now process priority. So process priority, what is the priority value of processes? So that depends again operating system. If you are using priority based operating system, like operating system also comes with a non-preemption, priority, non-priority, yeah. Now the priority value assigned by the operating system only, what is the priority of a current process, we can say. Now so type of a process, just now I said type of a process, and state, very important. So this attribute is very important. State of a process defines what is the current state of a process. Does process waiting for something, or does process is executing, or does process memory? What is the current activity of a process? What is the current state of a process defined by the state of a process? Yeah, the PC is type of register. PC is a register only. It's not type. It is a register. Please, program counter is a register, part of the processor. Accumulator, you might have learned accumulator, memory address registers, memory data register, instruction register, stack pointer, like index registers. These are all registers only. PC is a register, program counter is a register which have address of an instruction to be executed in the next sequentially. Clear? The points is clear? Saurav? Okay, now see, the PC program counter, general purpose register, special purpose register, priority of a process, type of a process, and the state of a process. What is state of a process? Defining the current state of a process. So further I will do the discussion of the state, but you understand. So next, third type. So like just taking memory related attributes. What is the memory related? Size of the process, yes or no? When you create a process, nothing but for program only something added. So that what is size of the process now? Now we have to store this program in memory, right? We are storing process in memory only. We are storing. What is the starting address of the memory? We say like memory limits. So memory limit. So limit register will be there, which pointing what? Which points is starting and ending address. If suppose paging is used, so page table address. If TLB also used, TLB things, as our segmentation concept use segmented table information. So these are the memory related information also we keep for each process, because for each process separately we create a page table, because as of now do not misunderstand, because this thing you will understand when we start discussing on the memory management, because this is completely related to memory management. Just as of now, just look at the names. Yes, this information also we keep. Page table information, the table which used to translate the address from logical to physical address. So that information also we can keep, like if this is supported. If segmentation concept is supported, segment table related information need to be keep. If both are there, both need to be use it. Clear? Now fourth one, file related information. What is the file related information? Please understand. In a secondary storage devices, our information we store in terms of files only. The basic unit of storage, storage unit in a what secondary storage device, files form only. Some standard files are referred by each process. Some standard files are used by the process. We say list of open files. List of open files means some standard files will be there. One is input file. Second is output file. The third one is some error file. Please observe. So like for process, input comes from the keyboard only, right? Input comes from the keyboard. We throw output into monitor. Error also will throw on monitor only. So there are three standard files referred by the process. So this is essential. And the fifth one, device related information. So let's take suppose this particular process referring some devices. So list of devices it is going to be used. Like that information also will keep it. Sixth one, accounting information. So accounting information, please understand. The time of loading, the arrival time of a process. Arrival time of a process means the time at which we store the process in memory. And how much CPU time required, expected CPU time or real CPU time. So these are the accounting information also we keep for each process. So file access. So you are saying that file access also, like file permissions also we keep. Yes. See, like especially you understand, file attributes also separately will be there. No, file name, file type, file size, file operation, that separate things will managed by OS only. But here is list of open files means what are the essential files which is going to be used by the process, or what are the files which is going to be used during life cycle of a process, during its execution. Sometimes randomly, example you see some shared memory, shared data is there, that is stored in file form, that may be referred. But I mentioned these are the standard. If other files are not required also, these are the standard files the process has to be used. So that's my point. I hope this is clear. Yes, please respond. Chalo. So the basic idea, like these are the various attributes of a process will be there. So these various attributes of a process need to be maintained so that operating system can take the wise decision during the process executions. The various times the OS has to take the decisions on a processes. So that based on looking into this attribute information only. Clear? Clear ma? Clear? Now I am writing the above. So this all attributes, please understand, all attribute information, all attributes information, okay, information, attribute information, okay, whatever so far I mentioned, all attributes information is kept in a data structure called PCB. It is very important ma'am, PCB, because as I mentioned, right, attribute information of a process need to be maintained by the operating system to take the proper decisions. But where to keep this information? The all attribute information so far listed are stored in a data structure which is created by the operating system is PCB. In that PCB we keep. Clear? The line is clear, all of you. So where we are storing this all attribute information? PCB. Okay. Now question comes here. PCB. What is the PCB? Yeah. Please answer. PCB refers what here? Process control block, this abbreviation, but tell me what is PCB now? So the few points I can write it. The PCB, what I said you? PCB is a data structure. Which data structure, sir? PCB is a kernel data structure. Is a kernel data structure. Kernel data structure. Okay. Kernel data structure means created by whom? So this is created by whom? Created by the operating system will create. Operating system will create. Clear? Clear. What is the purpose, sir? Purpose is simple. PCB is used to store what? Store what? Attribute information about a process. PCB used to store attribute information about a process. Please understand. So now, sir, does one PCB for every process? Yeah, Saurabh ji, like so 2-3 session, like session number 2 or session number 3 have been discussed very clearly. Types of mode, like 2 modes, essential modes of a system would be user and kernel mode, I said. So those things I discussed, but right now I will tell you, but I am suggesting after this session kindly go and see the list, like the various topics which I discussed from the operating system, kindly go through that. You will get more clarity over this. But I am just briefly telling you, kernel means, please understand, core part of the operating system. Simply to protect the operating system, code, entire operating system programs we executed some mode. That mode is called kernel mode. Kernel mode is nothing but protected mode. Means in that mode any program is running, it is protected. Nobody will interfere while a program is running in a kernel mode. Clear? My statement is clear. Kernel mode, if I say, that is protected mode or system mode, privileged mode we call, in which programs or application being executed without preemption, without interruption. Nobody will interfere a program who is running in a kernel part. Reason is to protect the operating system, we run that way. But other mode also will be there, like user mode, where our user programs will run there. So during execution of our user program, preemption can happen, interruption can happen, anybody can interfere, because there is no harm to our user code. But the same thing cannot be done for the operating system code. We should protect, so that we are running in that mode. So kernel is nothing but your operating system. Kernel is nothing but your operating system. Clear? That is the reason we call kernel data structure, means OS data structure. Yeah. So I try to convince this one. So got it right? Saurabh, respond. Okay. Now see. The PCB used to store the attribute information about a process. Now question comes, sir, how many PCBs will be there? How many PCB? Is there only one PCB for all the process? No. Please understand. The PCB, every process I am writing every process has its own PCB, ma'am. Its own PCB. Like see, when you registered in the college, like suppose when you joined the BTech program in the college, in the first year, initial days only you will get what? ID card you will get. Every student will get ID card or not? Say yes or no? Saurabh, every student will get separate ID card or not? What ID card is containing? Student ID card. What a student ID card has? Student ID card has first thing roll number, your name, surname, address, your blood group, your course, duration. So these few things will be there, right? Based on this, they maintain one record in the college, so that when I enter your register number, roll number, I'll get so much data. Example, you are in currently third year, so that when I refer your database, I'll come to know that you are studying in third year, how many subjects you've passed, like what is your credits, what is lab, all performance of a student I able to know or not through your number, that register number. So like see, your name is common, like your name may be duplicated with many people may have same name, but ID is only one uniquely, through which I can identify your information. So in an entire college, please understand, you are recognized by a ID card or not. Refer. In the entire your college life, during 4 years in that particular college, you are recognized by your ID card only, not by your name. Yes or no? Similarly, please understand, in the operating system also, in the operating system, process is recognized by the operating system by using PCB only. Operating system will recognize a process by looking at what is your ID card PCB, because operating system will not maintain the name of a process, it maintains what ID. So ID information is stored in the PCB, so that it will recognize by reading what PCB value only. Every process have its own PCB. In the college, 1000 students are there, 1000 ID cards will be created by the college management. In the operating system also, in the operating system, OS if it is created 1000 process, 1000 user process created means 1000 PCB, 1000 data structure created for each process. Sorry, all process. Means each process have its own PCB. I hope this is clear. Okay. So what I am trying to say here, operating system, OS recognize the process by what? By what? PCB only. PCB. Okay. PCB is not shareable, because every process having same separately. Is it clear? Is it clear, all of you? PCB. So now what I can say, process to PCB. Okay. 1:1. 1:1. I hope this point is clear. 1:1. Every process has its own PCB. It's not shareable. Okay. So any doubts here? Any doubts here? Any doubts? So now it is like it is serving as a PCB. Okay. PCB is like ID card of a process. ID card of a process. Can I say or not? Can I say or not? PCB is like ID card of a process. It has all attribute information. It has all attribute. Whatever attribute information, what is attribute information? It's all attribute information we kept. This all attribute information kept in process control block. So now PCB is also known to be process object. Process object or process descriptor also you can say. Process descriptor also we can say, because this is describing about a process. It is describing about process. Clear? Is it clear, ma? Saurabh, is it clear? Chalo. Now, so what is the start attribute information? So one of the most important attribute of a process, state. Okay. So please understand process states. So I am marking as a, what I am marking? Process states. one of the most important attribute of a process state. So process states I am writing. Okay. So process has various states. Process has various states. Means state, what state is defining, we will observe. What is the address of a PCB? Where I written address of a PCB means what? I did not understand. So you are saying that where PCB is loaded? PCB is loaded kernel part of the OS only. See, memory has two parts, user area, OS area. In the OS area, PCB will be there. Clear? So PCB address, wherever you have that address given to the programmer. So running, because PCB only will load into CPU state for running, so that it will read the data structure. You will see all the things inside from PCB only. Yes, I hope you understand, but suppose if you little more, if you elaborate your question, then I am able to answer it properly. Chalo, okay, now see the point. Process states. So what the process state means? Process states generally defines like activity. Activity means current state of a process defines by process states. There are various states, ma'am. So let us observe various states. The state can be new state, new. I will give a detailed information, new state. The state is ready state. Another state is running state. New, ready, running, block state, and terminate. So these are the various. Yeah, PCB resides in memory. Which memory? OS part of the memory, because created by OS will maintain the data structure. So the data structure will load for CPU state for execution. We will discuss when I further things we see, we will understand. Okay. Now look at the process states. Okay, process state. What I am trying to say, the process state defines the activity of a process where the presence of a process, where it is present right now, like current activity only you can understand. New, ready, running, block and terminate. There are, so initially 2-3 states were there, but the general state of a process would be 5, even more less also, but we will discuss. So new, ready, running, block and terminates. So let us understand one by one. So if I say new state, what does mean new state? Please observe clearly, because I will be defining each state, importance of each state, then also we see again process states, transition part also will observe. So new state is a new, please understand. If I say new state means process being created here, process being created here. Okay, please understand. So simply creation of the process happens here. Creation of the process happens here. That is creation of process means what? Creation of process, nothing but resource allocation also will take place. Resource. So resource allocation. Creation of process and resource allocation will happen during new state. What does mean? So resource allocation means you understand, suppose the essential files need to be added, some resource, let's take some registers need to be added, or some device need to be allocated, or you want memory we allocate also. Other than understand PCB also creation, please observe. The time of new state only, at new state time only, PCB also created. PCB created and allocated to a process here. Please observe here. So as I mentioned, right, PCB created by operating system only. So all attribute information process will keep and be given to a process. Yes, you got ID card, like see during admission time, the time of you took admission, within a time only you will get ID card, right, from the college, because you will get the register ID. So all various information they will add and you will get, but generally it will be delay within first week time. The first year only, first moment only you will get a ID card or not. Similarly here only, that first state of a process when you start creating Creating nothing but we start adding all resources and we load them into main memory for execution. Like this happens. Clear? So now please write down this point. Now another state is called ready state. Okay. Ready state, please observe, ready state. Okay. Now new state, what happens? We create and assign all the resource. Okay. Now just we start loading into memory also. But you know, ready state, if I say process, please observe. When I say process and ready state, process is in main memory, please. Main memory means from new state, when the process got created, we store this, we load the program image, process into where? Memory, main memory. That is the reason I am saying process in main memory. Also I mentioned, whenever a program in main memory called process, presence in main memory indication by ready queue. Ready, when I say ready state, ready means what? Process in main memory is just waiting for allocation of the CPU. So first I am telling process in main memory and okay, so just waiting, okay, just it is waiting for allocation of the CPU. Allocation of the CPU means whenever process in memory, I am just waiting for acquiral of the CPU. The moment CPU gets to me, I will start execution. So resource allocation means file device access permission, exactly, and the specially means files, memory you understand, some other registers also you understand, and the device also you understand, like the computer system resources we are allocating to a process. Correct, whatever you are telling is right. Okay. Now see, though it is in main memory, just waiting for what? Allocation of the CPU. The moment the CPU allocate to a process, start execution. Clear? The line is clear, this line is clear. Whenever I say process in ready state or ready means I am ready to execute with the CPU. I am just waiting for CPU allocation. Clear? So next state is what? Running state. So please understand the flow step by step also. First I created a process, then I load into memory, I am waiting for CPU. Once CPUs get, then we can start execution. Please understand. Running state means, please observe, running state nothing but CPU, okay, CPU started already, okay, started the execution of the program instructions one by one. Means whenever if I say a process in running state nothing but literally executing, literally using the CPU for executing the program instructions. Program has 10 instructions, started instruction by started executing already. So then we say process in running state. Running means using the CPU here. Still we call process only. If the process in memory, the program in memory, we call process. If the program in running state, we call process. If program in block state, we called a process only. If program in secondary memory, we call program only. Please understand the differentiation. Whenever a program is secondary memory, we call program only. So that program when you load into main memory, we call process. Clear? Clear, right, Saurabh? The point is clear? Chalo. So I hope you understand. Literally started executing the program instructions. Now, so next state is block. So block state also we called IO wait state. We called IO state or IO wait. Okay. So means please understand. So now what is the state, block or IO state defines here, please observe. So process, okay, process is in main memory only. Main memory, okay, main memory. Process main memory and it just waiting for an event to occur. Meaning what? Here please understand. Sir, at a time how many processes execute by CPU? So that is easy thing, like you understand, there is only one process. See, One CPU can run one process only at a time, not more than. So, the detailed things we will discuss again, but try to understand right moment. If I say only one CPU is there in a computer system, at any point of time, please understand, whatever mechanism used, only one process can run in one CPU. In one CPU, you cannot run two programs at a time. Is it clear? Now see, when I say process in block state IO state means running process may require an IO activity. Running process may require an event to occur, meaning example say. So, running process may expecting the data from input device. I want to read the data from input device. The device has to transfer, right? So, you have to wait in IO block. You have to block means nothing but you have to process has to move from running CPU state to IO state for completing the task. Otherwise, you understand there are two processes available A and B. They are communicating each other. So, process A sending a data to process B while executing. Process is executing in a CPU state, sending a data to process B, both are communicating. Now, process B has to receive the data and respond. Now, once data transmission of a process A is over, please observe, now please observe. So, process A has to wait, for response from the process B. So, now process has to move from running state to IO state to wait for the process B response. Other way understand. So, process A requires some printer to use for printing a file. Now, process A has to move from running state to IO state for using the printer to printing the file. So, that process is moving. Still that process in main memory only. Yes, when a program is loaded in main memory, we call process, that is it. So, till completion, please observe. So, whatever the times you see program in present main memory means you declare that is process only. Whenever the program is moved from main memory to secondary memory, you call as a program only. Clear? Yeah. I hope you understand this line. IO activity means clear, right? It can be IO activity, it can be communication, it can be some event to occur, or maybe process want to use some file is not available, shared file I want to use it, the file is busy with other process, I have to wait for the file to be available so that I can use it. So, there whatever other than CPU activity required, so that process will wait even to satisfy that particular event. I hope this is clear. So, next another state is what? Terminate. Another state is terminate. So, terminate means end of the program. End of the program is program execution over, program execution completed, process completed its execution. So, termination means releasing the resources. Whatever so far resources are given, you have to release it. Releasing the resource, a deallocation of the resource happens. So, termination state only. I hope this is clear. Process, please understand, successful execution will complete from running state only. In a running state, every instruction, everything is task is over, it has to leave from the running state. Successful termination will happen from running state, and normal termination from the running state, abnormal termination. Sometimes error occur. Error may occur running state, error may occur ready state, error may occur in IO state also. Such cases we have to throw. Process can share a data with other process. Yes, it can share a data. So, that we want to do it, right. That is only we go and study inter-process communication. Inter-process communication means two process, they want to communicate by transferring the data, or these two processes may be communicating by sharing of a data. Resource sharing, data sharing, presence, yes, process can share. But we should ensure that the data while sharing, like read and write operation should not happen simultaneously. That we have to ensure that one, because otherwise data going to be inconsistent. That can be taken care. So, in synchronization mechanisms. I hope this is clear. Okay. The 5 states are clear, all of you. State number 1, new, ready, this is running, this is 4th IOR block state, 5th is termination, 5 state model. Is it clear? Sarob, is it clear? Respond. Total 5 states. So, ready, process creation, waiting for the CPU allocation, execution with the CPU. If required IO activity you have to do, then terminate. So, these are the 5 state model, 5 state model. Fine. Any doubt till this point? Do you have any doubt in this point? No doubts, right? Respond, respond. Till this point, do you have any doubts? Okay, okay. Now we will observe. Now we will observe. Okay. So now, so process states we understand. Now let us observe the process states, state and its transition diagram. Transition diagram. Process states and its transition diagram, which very important topic. Observe, very important thing is this. Now this depicts the current activity of a process, current activity of a process defined by the process state transition diagram. Transitions, various transitions of a process will observe. Fine. What are the states I mentioned? New state, ready state, running state, wait or block state. Last one is what? Terminate. These are the 5 states we have seen, right? Yes or no? Now see the various transitions. Now let us see the various transitions on this states. Okay. So please observe clearly. The first state is a new state. Please observe. New state. Okay. What is the purpose of new state? Tell me. Where a process gets created. Program we are creating into process, allocating various resources. Whenever process get created, creation is over. When the creation is over, please observe. When the creation is over, it is moving into another state called ready state. We call ready state now. Another state is called what? Ready state. Please observe. Another state is called ready state. So now see. So after creation, now created, process got created. Please observe. Okay. Process got created, nothing but various resources allocated. PCB also allocated for each process. PCB of a process, the data structure. PCB the data structure, right? PCB of a process we are loading into ready state. Ready state can accommodate more than one PCB, more than one process. Process image we are loading into main memory. Further relevant ID card we are loading into a ready state. ID card only will come to ready state. My entire code will not come. Program code support 100 KB is there. 100 KB data it won't come to ready state. For that 100 KB data process we created a PCB. PCB is the data structure having all attribute information, right? That ID card only we are moving to here. Am I right? This is clear, ma? Point is clear. All the ID card of a process only we are loading into ready state here. Ready state nothing but it is in a main memory only. Means process just waiting for CPU allocation. Now another state you observe. So running state, running. What is the running state indicates? What is the running state I said? Running state nothing but where programs instructions started execution. Now observe. So now ready queue having more than one PCB, more than one process. Let's say 10 process loaded, 15 process loaded. Now operating system scheduler, CPU scheduler we call CPU scheduler. Sorry. Now Rediq is having more than one PCB. Maybe it depends on the operating system. We stored many. Now short-term scheduler or CPU scheduler is functionality to select one process among the ready process and assign to CPU. So that transaction we call schedule, dispatch. Okay. So dispatch or schedule we will call. Start opening into PCB, you will reading the information. What is this process? Let's take example. What is the current value of PC? Take the PC value, read the PC value, go to memory, fetch the instruction, execute it. So that executions happens here, right? Now this running process, observe ma. Carefully observe Saravji, try to carefully observe because this transition is very much important. Now I created, after creation I am loading here, then I am scheduling based on the availability of CPU. Now process started execution. If the running process required any IO activity to be done or any event is occur. So now I am marking here any IO or event occur. So running process comes to IO activity. So now other process we schedule because multi-program environment means whenever process moves from running state to IO store, other process can be scheduled so that this will be always busy. Okay. Now parallelly can be done. One process can do IO activity, other process can done CPU activity also because both are independent, right? IO activity different, CPU activity different, parallelly can be done. I hope this is clear. Saurav, respond, this is clear or not? Running process move for IO, other process can be scheduled, it can run, fine. Now suppose if this IO activity is the process waiting for some usage of device is available, using the device, IO activity is over, or some you are waiting for an event is satisfied, then running process, this block process has to move to ready state, not to the running state. So now I am marking IO or event is satisfied, then process will move to ready state only. You have to wait for the again allocation. Clear? This is clear, right? Now suppose I loaded here, is running, so execution is completed. Execution completion nothing but what should I do? Terminate it or not? Terminate. Here terminate state is there. So execution completed means termination. So this transition name is what? Execution completed. Execution is what? Completed. Terminate the process. Clear? This transition is clear? Yes, Saurabhji, tell me. Transition is clear, right? Very simple. First initially we have to load all the process PCB into here. CPU scheduler will pick one process and schedule for running. So you have to run. If successfully completed, terminated. If required any IO activity or any event is occurred, you have to just wait for the event is satisfied. Further you have to move to ready state, you have to wait for again CPU allocation. Once you get the CPU, just again do it, then terminate the process. This is the transitions happens now. So now process is moving from state to state or not. So this only will refers current activity of a process defined by the process state model. I hope this is clear. So apart from these 5 models, two more states I will be introducing. So one is ready. So one is ready suspend state is there. Ready suspend state. Okay, ready suspend state. Another one is what? It is a block state, right? Block suspend state will be there. Block suspend state will be there. Okay, there are 2 states I am introducing here. Is it visible, right, all of you? Is it visible, right, all of you? Respond. This is a ready suspend state. Okay, this is what? Block suspend state. There are 2 states I introduce here additional. Naturally 5 will be there, but 2 more also I have introduced. 2 more also I have introduced. So let's observe the ready suspend and block suspend state. What does means we'll understand. What does mean we'll understand. Okay. So now I will write it here. Here I will write it. Okay. Here only I will write it. Suspend meaning what? What is the meaning of suspend? Can you tell me what is the meaning of suspend? Suspend means temporary. So send a process image means program. Send a process image into disk temporarily. So in the event of, so event would be anything like, no, event would be suppose memory is not sufficient or resources not available. In the event of, I can say, in the event of lack of memory or resources. Okay, clear? Suspension meaning what? So now process will move from main memory to secondary memory by the operating system. Reasons are, there are many reasons, but let's understand. I'll give the many circumstances where process required to be suspended into secondary memory. Suspension is simply moving from main memory to secondary memory, that's it. Okay, now see. So I am just talking about ready suspend state. I am talking about ready suspend state. Okay, please observe. Ready suspend state means what? What is ready suspend state? Observe here. So a process, ready suspend state means a process is in secondary memory, ma. Please, secondary memory. Are you getting my point? Secondary memory. Okay. If I say process in ready suspend state, that is in secondary memory, and waiting for the execution as soon as it is loaded into main memory. Simply no, just waiting in secondary memory. So I am ready for execution. As soon as the process is loaded into main memory, you can start execution. So that is the purpose. This one, okay. Then why process we send here, I will tell you, we will discuss. Another state. What is the another state? Block suspend. So a process in main memory, please observe, and waiting for an event to occur. Okay, now see, observe. When I say process in block suspend, so that, sorry, this is also secondary memory. Sorry. This is also secondary memory only. Okay, now see. So secondary memory and waiting. Okay, process will be secondary memory. We send secondary memory. Blocked process we send it secondary memory, but event is not satisfied. It's just waiting for event, because example IO is waiting for IO. IO should be completed, or he may be waiting for other process to respond. He has to waiting only, or maybe system call occur. It is waiting for two system calls should be created. Clear, ma? Is it clear, all of you? Meaning, so I'll come to this state again. Sometime process from ready state we are suspending into secondary memory. Sometime I blocked process also we are suspending into secondary memory. What are the circumstances? Process will suspend secondary memory, we'll observe. Normally in this, the 5-state model, if you see, all the time process in main memory only, but running process are sometimes loaded, where the memory loaded into memory process also we suspend secondary memory. Some reasons will be there. We'll take the circumstances clearly. Look this, all of you. So now sometime process we suspend from ready state here. Suspend. Okay. What is the reason? I'll tell you. Example, operating system loaded suppose 100 process assumption. Carefully observe the situation. Operating system loaded 100 process. They are started executing. Some are in waiting state, some are in ready state. One is executing. This is scenario happening. In this moment, operating system willing to take additional process, that is high priority. Operating system willing to take additional process for execution. For that, memory is not available, because 100 process loaded in memory. Suppose main memory is full, but for new process there is no empty space. Then operating system definitely has to take a decision. One of the process need to be suspend, send into secondary memory temporarily, load the high priority process into main memory, executed high priority process. Once high priority process over, then you can resume the suspended process. Are you able to understand the situation, all of you? Everyone please respond. Are you able to understand the situation where process required to suspend? The situation number 1 I said, high priority process want to bring no space available. Now the process who is waiting ready state, because ready state nothing but generally having the fresh process, recently loaded process. So suspend temporarily. Then, so suspend, move to secondary memory. Then high priority process loaded and executed, suspended. Now based on the availability memory in ready queue, later we can resume it. Resume means what? Suspended memory process can take back into main memory for execution based on the availability. So this transition is clear. Now here block suspend also mentioned. What is a block suspend? Sir, blocked process also we need to do suspension sometime. Why not ready, sir? Please observe, among all the states, desirable state for process suspension will be the ready queue only, ready state only. Ready process only will suspend, not other thing. But sometime, please understand, some situation may occur, blocked process also need to be suspended in secondary memory, running process also required to be suspended. What are the situation? Let us understand. Some situation, please, I'll making you dotted line here. So dotted line I'm making dotted line. So suspend. Okay, suspend. Okay, getting my point. So blocked process meaning what? Blocked process came from the running state waiting for an event, waiting for some IO device. So waiting for some IO device, that process we require to suspend. Reason you understand. There are no ready process here. So 100 process are all 100 process came to IO state on assumption. Most of the process are IO process only. There are no process in ready state. So ultimately operating system has to suspend one of the blocked process secondary memory only. This is only circumstance. Or some situation, maybe some process ready state or some process here. Operating system willing to take the decision, willing to take a process from block state for suspension. Reason, this process may have more memory, so that much memory may require for the new process. There is no any process in the system, so sufficient memory has other than this blocked process. Such situation, operating system will suspend the blocked process only rather than ready process. Naturally, operating system will try to find a process from ready state for suspension. In such a situation, it won't get it. So that cases it will choose a process from block state for suspension. Clear? This line is clear. What are two situations? One is there are no ready process in a ready queue. So blocked process required to choose for suspension. Other cases, blocked process may have more memory. Maybe this is only high priority process or low priority process among the processes, so that we have to be suspend. Now based on sometime we need to resume. So this also resume. Resuming nothing but see. Maybe this is a resume line I am writing. Resume. Okay. So there is a high priority blocked process that is soon it becoming unblocked. There is a among the system process in a suspended state is high priority. So that need to be unblock it so that it will quickly complete the IO activity, come back to ready queue, then you can start execution. This also possibility. Now, so one more thing need to be ensured. Whenever you suspend the blocked process into secondary memory, we must ensure that IO activity parallelly should done. IO activity should be done. Once this IO activity is over, please observe. Once this IO activity is over, the process eventually will move to ready suspend state only. So whenever IO or event completed, event is completed means the process who are in blocked suspense state, parallel they should finish the IO. Once IO activity is over, the process is what has to go for ready state, but directly we won't send the ready state because ready state might be full. So we have to send into ready suspense state. In the ready suspense state, the process just they are in main memory, secondary memory they are waiting for execution as soon as they are loaded, just waiting for that. But process are in if you say process secondary memory here block suspense state, they are in secondary memory, they are not ready for execution, they are waiting for what? Event to occur, event to satisfy. Once event is satisfied, it has to move for here only. This is a transition. So dotted line I mentioned here. Clear? So this dotted line indication is not desirable suspension, some situation required to be suspended. But here mandatory line mention operating system will pick a process from ready state. Some situation please observe running state also, from running state also process gets suspended. Understand? Like there are many processes available, one process running here, assumption. Operating system to willing to take a additional process into memory for execution. Okay, memory is not available. So generally operating system will choose some lower priority process for suspension. That lower priority process may be running here. Lower priority process running here, high priority process want to come to system. Such case running process we preempt, running process we send temporarily into secondary memory, allow the high priority process to run, load and run it. Once high priority process over, then lower priority process can be again reloaded into main memory for execution. So that is the reason I mentioned dotted line. Dotted line indication, it is not a mandatory line for suspension, some situation required to be suspended. So this only. So like in a gate question many times also seen, like one of the paper I have seen. So again, which of the following state is a desirable state for process suspension? What is the answer? Can you tell me? Statement is what? Which of the following state is a desirable state for process suspension? They given running state, block state, ready state, new state. What is the answer? Ready state is the answer, please understand. Desirable state is other are optional, which are not mandatory. Yes, this is clear. So this is completely 7-state model. So I presented here. So this is extra 2 things are mentioned for under memory multi-programming environment. So that also you need to understand. So one more thing also I want to show you, preemption, like preemption. So now we have studied multi-programmed operating system can be preemptive based and non-preemption based. Presence of transition from running to ready, indication preemption means whenever. So when we do preemption, when you load a process for running, now suppose under time sharing system, the process has to use some equal interval of time. Once the time, allowable time is expired, eventually preemption will happen. Running process will send back to ready queue, other process need to be loaded. So this is a transaction which it defines. Everybody just respond. Is it clear? Is it clear? Process transitions, all the process transitions is clear? Respond everybody. So please do copy some questions or some analysis on this one we can observe. Okay. Now I'll be asking, like in a gate paper also we expected some questions. What are the possible transitions, ma'am? Possible transitions. What are the possible transitions? Transitions, yeah. The first one, you say yes or no, this is possible or not. So new to ready means process need to move from new to ready. Is possible state? Yes, this is possible because we have to load a new process only. Second one, ready to running. Tell me possible or not. So running to ready. Fourth one, running to block state. Fourth one is running to block state. Fifth one, block state to running. Sixth one, running state to termination. Seventh one, new to running. Next state, new to or ready to termination. So tell me now, what are the possible states here? What are the possible states? New to ready, possible. Ready to running, yes, dispatch schedule will do. Running to ready, yes, preemption case is possible. Running to block, whenever IO required. Block to running, not possible. Under multi-programming environment, please observe, I am taking the scenario multi-programming operating system. So block to running is not possible. Only running to ready is possible. Running to termination, yes, new to running. So new to running is not possible under multi-programming, because newly created process you have to load into what main memory, that is a ready queue, first you have to load it, because we don't know availability of the CPU. So you have to, not possible. New to running, only new to running possible under uni-programming operating system, not multi-programming operating system. Ready to termination, yes, this is possible. From ready state also process can be terminated. Let's take example, understand. So process is there, it is created children. If suppose children is creating some problem, error is occur, parent can terminate the children at sitting at a ready state only. This is possible. Like this, there are many combination, many possibilities we can observe, but you understand sometime, like in a previous year papers I observed some of the transition they given, they asked which of the following transitions are possible. MSQ questions, they asked MSQ, multiple select question type we can expect it from the gate paper, based on what? Based on what? Based on what? Process transition diagram here. So few other more points we can observe here. So now last question, this transition diagram represent the multi-program operating system or not? Yes, it is a multi-program operating system. How to identify, sir? Presence of ready queue, please observe, presence of ready queue indicates the multi-program operating system. If ready queue is not present, that is a uni-programming operating system. I hope this is clear. Now next question. So this process transition diagram is a preemptive based multi-programming or non-preemptive based multi-programming. How to understand? So presence of this transition from running to ready, presence of transition from running to ready defines the preemptive based multi-programming operating system. I hope this is clear. So this kind of observations we can do it. Okay. So now I hope you understand. Please copy properly, observe the statements whatever I given here, then understand yourself. Now remaining things I would like to continue into in the next session. In the next session we will observe the various schedulers, various queues maintained with the operating system, and various schedulers and dispatcher part we will cover into in the upcoming session. Thank you so much.